Hi kids, welcome to another video, Module 5, Lesson 12. And the objective here is we're going to measure to find the area of rectangles with fractional side lengths. You will need a ruler, and I hope you have one. Any straight edge will do with numbers, and you only need something to be as long as the biggest figure in your book, which is only about 3.5 inches long. So, any small, if you have a 6-inch ruler, that will do. So go grab a ruler, pause the video. Then when you come back, we're going to measure each rectangle to the nearest 1/4 inch with your ruler, and we're going to label the dimensions. Now in the previous video for lesson 11, we were tiling and looking at all the tiles as well, if this is a 1 by 1 square, then I can count the ones. So today we're going to kind of take that and expand it just a little bit more, and instead of having 1 1 1 1 1 1 1 1 1 all over the place, we're going to actually put in, okay, well this might just be 6 units squared. And so we're going to do that, and then we'll take our fractional units and add them together to find the total area. So it's a little bit different from finding the length times the width and using the formula we've been using all along. It's kind of like, oh, here's an alternate way to find area. So we are still finding area, but a different way. So get that ruler. Watch out when you measure. It's usually not at the end of the ruler. It's this little hash mark right here that starts the 0. And so you want to look for the long line. And when you lay it right across it, you can see that this line here is 2 inches. And so you want to label everything. And then turn it, and again start on the 0. And you notice, this is in between the 2 and the 3, and it's actually 2.5. Very important that you mark right here that this is where the 2 inches ends. And we're going to take this little hash mark that you just made, and we're going to section off this bottom chunk because this is a 1/2 inch. So kind of like we did yesterday with like 1 plus 3/4. This is going to be 2 plus the 1/2. So the 2 inch by 2 inch, we're just going to label this 4 inches squared right in the middle. So big fat area label right in the middle. And then what do? We're going to take our 2 inches, which is all the way across here, by the 1/2, and we're going to multiply it so that we can label this 2 times 1/2 equals 2 halves, which equals 1. And so this is going to be 1 inch squared. And then we're going to put those together in our final area for this figure. So that is what lesson 12 is about. Now there's a whole bunch more, so we have to get to it. Part B. When I put the 0 here, I can see that I am, not quite all the way. If you do a little closer, it might actually be better. Here's my 1, and it's at 3/4. So this is 3/4 inch, and this is going to be the 1 inch. And then turn your ruler, and if you have 2 dots, it's nice and easy just to put the line down. Now measure the side, starting with 0. Go all the way down. It is also 1 3/4. Mark a little hash mark. This is 1 inch. This is 3/4 of an inch. Take your ruler, turn it, make a line that's parallel with this one. If I'm going too fast, you can always click the little gear thing and slow this down a bit. Then you're going to label inside each figure the total area by doing the math. So we know that this is 1 inch squared because it's 1 times 1. So this is one of the only ones where it's going to work out like that because it's such a small box. And we know that this is 3/4 times 1, so I don't really have to do that. I can just put 3/4 inch squared. And I know that this one is 1 full this way by 3/4 this way, so it is also 3/4 inches squared. But this little section here is the 3/4 by 3/4. So if you're not sure what that is, then set it up over here and multiply and get 9/16. And then you can label that in units squared or inches squared. We're using our inch ruler, okay, to the nearest quarter inch. So everything is in inches. But now I still need to get the total amount. So we're going to combine by adding. And this is a throwback to Module 2, adding and subtracting fractions. They have to have common denominators in order to be added. So I can combine these two for 6/4, which is actually 1 2/4. And when I combine that with the 1, I have 2 2/4 plus 9/16. But I need to have a common denominator before I can add. So don't get it mixed up in this part of the problem, and I still have to have room to label that. So we're going to change our fourths into 16ths. So 4 times 4 is 16, so 2 times 4 is 8. 8/16 are equivalent to 2/4 plus 9/16. And that will give us 17/16, which is equal to 1 1/16, which we will combine with the 2 for a total of 3 1/16 inches squared, smashed into the edge of the paper. And I did it. Okay, and then we're going to move it up and do C next. Get your ruler. Okay, put it on 0. Mark again that this is at 2 3/4. Here's the 2 right here. This is 2 inches. This is 3/4 of an inch. Okay, that's not squared. On the outside, notice everything is just linear units, and on the inside, everything is square units because we are showing the squares on the inside. Now, what about this side? Okay, putting it at 0, it's 2 inches exactly. So I don't have any fractional parts on this one, and I have 2 times 2, which is 4 inches squared on the inside. This whole thing would be exactly 4 squares. Okay, and then this one is going to be the 3/4 times 2. And you can cross cancel here. And you get your 1 1/2 inches squared. Okay, now write it in an addition problem. And have your area all calculated because of your previous solutions. So nice. Move on. There's still a lot more ahead. Okay, so starting at 0. Now notice this one only gets 1/4 of the way. If this is the half and this is 3/4, this is only 2 plus 1/4. So I need to make a little mark right here. This is 2, and this is 1/4 of an inch. Now section that off. Make that nice parallel line with the outside. And then you can measure the this side. It goes all the way to 3. Okay, and that's going to be, put your line there. Sorry, clean it up. And you have your 1/4 right here. Okay, so we have 2 1/4, and then 3 1/4. So 2 times 3 is 6. So you can just put your 6 inches squared there. But for this section and for this section, you need to multiply the length times the width. And so for the first one, it's 3 times 1/4 for 3/4 inches squared. And then this one, of course, is going to be 2 times 1/4 for 2/4 or 1/2 inch squared here. Now this tiny bit, you cannot forget about it because it is part of our final calculation. It's going to be the label for the top, the 1/4 by the 1/4, which makes 1/16. And that is what this is here. And that's going to be part of our final calculation. So let's put it all together. We have 6 plus 3/4 plus 1/2 plus 1/16. Can't add unless they all have common denominators. I can't make this any smaller because it only has a 1. Okay, so it can't get any smaller. So everything has to become 16ths. So 4 times 4 is 16, therefore 4 times 3 is 12. This has to become 16, so 2 times 8, therefore 8 is now on top. This one stays the same. Combine all your 16ths. 12 and 8 make 20, plus 1 is 21. Down here at the bottom. And then 21/16 has to be changed into a proper fraction. And we'll do that here. One time with 5 left over. And then add that so that you get 7 and 5/16 inches squared down in the corner. And that is our total area. Okay, all right. Now this is just kind of the weirdest thing. If we do run short on the video, I will get you all the answers. Don't worry, because there are 2 more pages of stuff. Let's get to it. 2 more figures to measure. Take this one and notice that it is only 3/4 of an inch. And then this one on the side is 2.5. So we're going to mark where the 2 is. This is the 2 inches. And then this, of course, is that 1/2 that you want to label, 1/2 inch. And so in order to find out this section here, it's got to be 2 times 3/4. And we have 6/4 for 1 2/4, which is also equal to 1.5. You can use either of those depending on what you need if you have to add later. Inches squared, same thing, either or. Okay, that's an arrow. And then for the bottom part, we have 3/4 times 1/2. So you're finding small amounts, which is supposed to make things a little bit easier instead of having big gigantic amounts. And then you take your 1.5, but see, we have to have the same denominator, and this has 8ths. So it's kind of like whatever you think is easier to work with. You could use 1 2/4 because you know 4 times 2 is 8. So let's just do that one. Plus 3/8. So now I only have to change this from 1 2/4 to 1 4/8. It's times 2, so times 2. And then you get 1 7/8 inches squared for this one. And give us a little bit of room for F. Okay, measure, get your ruler, measure carefully. Hold it at the 0. It's 3 3/4 with the 3 being here. 3 inches, 3/4 of an inch. Put your line here to section this off. And then for our 3, got to measure. This is going to be 1/2 inch. 3/1 times 1/2 equals 3/2 and 1.5. 1 1/2 inches squared for this part. And then for the tiny part, there you go, 3/8 inches squared. Again, we have to have a common denominator, so this is what would have happened over here. When you go to add your 8ths, you have to convert this into 8ths. But it's okay. You still know that 2 times 4 is 8, so then 4 would become our numerator. And then we got 1 7/8 inches squared for this one. Okay, so they are both the same area, even though they look slightly different, but things can have the same area. So move this up, and let's take a look at the bottom. Find the area of rectangles with the following dimensions. Explain your thinking using the area model. So you are supposed to draw with your ruler and create the outside box and then mark it off. So keep that ruler handy. 1 foot by 1.5 feet, and you don't have to use the entire ruler. We're calling it whatever unit we want. So it's going to be a 1 by 1.5. Okay, and let's just do the 1.5. I'm gonna move it onto my flatter part here for a second. 1.5 by 1, and then good thing my ruler is flexible. Otherwise I might be breaking it as I bend it to make my fun little figure here. Okay, so once you've created your little rectangle there, then just go over it one more time so you can mark off where that inch mark is. And then separate that half section from the whole and label 1 inch, or sorry, let's call this 1 foot like they said, and the ½ foot. Sorry, it's a little messy. We will survive. And then this one is 1 foot here. So this is going to be 1 foot squared, and this is 1 times 1/2, so it's 1/2 foot squared. And so really it comes down to 1 plus 1/2 for 1 1/2 feet squared. And then explain your thinking using the area model. This is the explanation, so you don't have to write up a big old explanation in words because we've already shown it. So let's do another one. Oh, let's turn the lights on. Hello. Pretty soon the janitors will walk in. Hello. Okay, 1.5 by 1.5, so we need to make a perfectly square figure. 1 up to 1/2. Here's my mark. And then 1.5. Here's my mark for the 1. Close off your box. It doesn't have to be like 100% perfect. You just kind of want to have the general understanding. I am creating 1-inch squares or fractional units that you can then find the area for. Okay. 1, we're going to use their measurement yard. This is going to be the ½ yard. This is going to be the 1 yard, ½ yard. 1 yard square. 1 times 1/2, ½ yard squared. ½ yard squared, because it's again 1 times 1/2. And then this is 1/2 times 1/2 is 1/4 yard squared. And let's add up all of these 4 amounts. 1 plus 1/2 plus 1/2 plus 1/4. I know you probably wanted to combine those. I'm just showing you. You have to count all the pieces. 1/2 plus 1/2 makes 1 whole. 1 whole plus 1 is 2. 2 and 1/4 yards squared is your final area. So a little bit of mental math there is okay. You guys could see that the whole time, and if you couldn't, I just moved it up for you. Hooray! There's just no perfect way to do this because there's a pole in the way either on the left or on the right. So here, let's just section this off, and then I'll make my figure over here. It's going to be a 2.5 by 1 3/16. That's always fun when you have to get down to the 16ths, which are the little tiny pieces on your ruler all the way to, look at the little teeny pieces. There are 16 of those. See, 1, 2, 3, 4, 5, 6, 7, 8. 8 is the halfway point between 1 and 2, and then you continue 9, 10, 11, 12, 13, 14, 15, 16. So 2.5. It's going to be here. 2.5. This will be our 2. And 1 3/16. It's 1, and then look at 1, 2, 3. And then here's my 1. So down on the side for a full 1, and then 1, 2, 3 little spots. This might not be perfectly parallel, but we'll be all right. Section it off. Section it off. Okay, try to make it parallel with your bottom line. It's nice when you have a clear ruler because it really does help. So this is the 2 yards, half yard, 1 yard, 3/16 of a yard. That's going to make for some interesting calculations. 2 times 1 is 2 yards squared. 1 times a half is a half yard squared. 2 times 3/16. Now, if you can't think of that right off the top, you just go 2 times 3/16. And then you can see that it's the 2 times 3. And you can leave it at 6/16, or you can divide that by 2, which you could have simplified before you multiply. And then you can get, looking at the bottom, wrote the top, 3/8 yards squared. And then for this last little guy, it's going to be the 3/16 times 1/2, okay, which is what we just did. Oh, wait a minute. No. We did 2 times 3/16, and we're doing a half of it. Okay, my bad. Sometimes it's like, I'm tired. My brain. There we go. And you guys couldn't even see what I was doing. There's the work. And here is our 3/32. 3/32 yards squared. Now we just put those together. So 2 plus a half plus 3/8 plus 3/32. And you know, you have to have a common denominator before you can combine these. So you can put this together first because they're closer, or you could just make them all 30 seconds. So let's just make them all 30 seconds. If I was going to change from 2 to 32, that's 16 times. And then if I was going to change from 8 to 32, that's 4. This one stays the same. And then 16 plus 12, 28, 29, 30, 31. And it looks like the strangest answer you'll ever see, and that is the final answer. 2 and 31, 30 seconds, yards squared. Okay, now for the last page, because sometimes I do this and there is so much work on here, what I'm going to do is show you the final work. And I want you to just listen as I explain why, because when you see it, you're going to go, oh, heaven help me. All right, let's take a look. Hanley is putting carpet in her house. She wants to carpet her living room, which measures 15 by 12 1/3. She also wants to carpet her dining room. Here are the calculations for the dining room, which is 10 1/4 by 10 1/3. How many square feet of carpet will she need to cover both rooms? First, you need to figure out the living room with a 15 by 12 1/3. Please separate it out like this: 15 times 12 plus 15 times 1/3. Okay, it's going to be a little bit easier than having to do 15 times 37 thirds, which would give you a pretty big division problem. 15 times 12, mark it out over here. 2 times 5 is 10, carry the 1. 2 plus 1 is 3, hold that spot with a 0. 1 times 5 is 5, 1 times 1 is 1. Add them all together and get 180. Then you have to do the 15 times 1/3. So that's over here. You can cross cancel 15 over 1 times 1/3. And then cross cancel and simplify that because these are compatible. Use 3, and then you get 5. 5 over 1, which is 5. 180 plus 5. It's so much easier to do it this way than to wrap this up into an improper fraction. That's only the living room. So make note, we're only 1/3 of the way done with the problem. Dining room, 10 1/4 times 10 1/3. This again is kind of nice. If you just stretch it out, you're going to keep your numbers really low and simple. 10 times 10 is 100. So first times first, then first times second, then second times first, and second times second. That's what these are. 1, 2, 3, 4. Okay, that's what those are. And then you solve each one individually with the parentheses. 10 times 10 is 100. 10 times 1/3 is 10/3 because it would be 10 over 1. Worry about what happens with this later. 1/4 times 10 is 10 over 4. Worry about that later. 1/4 times 1/3 is 1/12. Now I have to put these together so that they all have 12ths. Okay, so just one step at a time. If I want to change from 3 to 12, it's multiplied by 4. 10 times 4 is 40. To change from 4 to 12, it's by 3. 10 times 3 is 30. Leave this one alone. 40 plus 30 plus 1 makes 71/12. And you can do the division if you want. Okay. And I feel like you can simplify before you do that as well, but since this is how I have it written, I'm just going to talk about this here. And 71 divided by 12 would give you 5 with 11 remaining. And so that is just for the dining room. Okay. Then you have to combine those two, the 185 plus 105 and 11/12 for both rooms. And there's only one fraction, so it's just straight addition. Okay. And as time ticks on, this last problem is another big guy. Okay, but totally doable. So here's the strategy. Okay, Fred cut a 9 3/4 inch square of construction paper for an art project. Here's the big square. Then he cut a square from the edge of the big rectangle whose sides measured 3 1/4 inches. By the way, click subscribe because I am going to try to help you on all of these hard problems. So he cuts out this little square of a 3 1/4 inch by 3 1/4 inch piece. So the strategy is, first of all, if you have to find the area for the whole thing that you eventually do, is find the area of the small, which is 3 1/4 by 3 1/4, and then subtract that from the entire area, 9 3/4 times 9 3/4. Okay. And again, separate it out. When you have bigger numbers, instead of having 9 times 4 is 36, plus 3 is 39, 39/4 times 39/4. You can do 39 times 39, and 4 times 4 is 16, and then divide that by, so it'd be 225 divided by 16. You can certainly do that if you want, okay? But sometimes it's just easier if you piece things apart. So back up here to A. 3 1/4 times 3 1/4, break it out. First times first, first times second, then second times first, and second times second. When you do that, you have these 4 problems that you need to solve. You get 9 plus 3/4 plus 3/4 plus 1/16. Turn these fourths into 16ths and combine everything. Okay, actually I did 6/4 first, and then made those the 16ths. And then you put it all together and get 10 9/16. That's the smaller square area, and do label it carefully. And then this one, 9 3/4, this is for the big square. And again, just separate it out so you get 81. And then sometimes you can cross cancel. When you can cross cancel, it really, really helps. Add up everything you can. Make everything have 16ths. Okay, 9 times 3 is 27, so you get that twice. Then we have 9/16. Turn those into 16ths, or add up the 27s first and then make it 16ths. And in order for me to get the mixed number here, that's where I did, oh no, I did a different one. Sorry, I was thinking that was 216 divided by 16. And so I added those. That's where the 225 comes in. So 216 plus 9 is 225. Then you do the division. Then you get this mixed number, which you combine with 81. Okay, and I sure hope this has been helpful. That's the final answer when you take your 95 and 1/16 and subtract the 10 and 9/16. You actually even have to do a subtraction with regrouping here. 95 minus 10, but it's 1 minus 9, and you can't do it, so then you have to take 1 and make this a little bit bigger before you can do the subtraction. So barely got it done. Have a great day, you guys, and I'll see you on the next video.